Today, we're going to end up using Snort to do some packet capture analysis. We're going to do some live investigations and everything else in between. It's going to be a really good video. My name is Hank Hackerson, your trainer for today. And to get more videos like this one, make sure that you like, subscribe, and turn on the notification bell. This is based on the Snort room that is inside of the network security monitoring module of the SOC level 1 pathway of TryHackMe, and this is for 2026, so this is the most recent version of SOC level 1. And we're going to end up using Snort to detect real-time threats, analyze recorded traffic, and identify anomalies. It's going to be a really good one. Very, very in-depth video. So we have introduction and the interactive material and the virtual machine launch, then the intro to IDS/IPS, first interaction with Snort, and then we got the operation. So operation mode 1, sniffer mode, packet logger mode is part 2, mode 3 is IDS/IPS, mode 4 is PCAP investigation, the Snort rule structure, and then we got the operation logic, points to remember, all that stuff. There's so much stuff. This is going to be a long video today, or at least that's what they say, because they say it's going to be 120 minutes to go through it, and then I'm going to be recording and explaining a bunch of things, so I feel like it's going to be probably around a 120-minute video, but there's going to be timestamps for everything down here, so you can jump around and find different sections that are most applicable to you and hopefully get the information that you really need and look for. Quick little note from Hackaholics Anonymous, and then we will dive into the intro and the lab setup. If you want access to my notes and exclusive downloads and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. Okay, if you were not with us in the last episode, Snort is an open source rule-based network intrusion detection and prevention system. It also can help you detect anomalies. It's signature-based as well as anomaly-based. It's a really good one. I like Snort. It's open source, so it's really easy to access and find and download. And it's actually very user-friendly as well once you kind of get the hang of just the basic rule sets. Really simple tool, very powerful tool. Developed and maintained by Martin Roche, I want to say, open source contributors and the Cisco Talos team, so you know they have a really good backing. Official description is that it's the foremost open source intrusion prevention system in the world, and it uses a series of rules that help define malicious network activity and uses those rules to find packets that match against them and generate alerts for users. The objectives are the overview of the IDS/IPS, the Snort overview, writing those rules, detecting intrusions with Snort, and the prerequisites would be network fundamentals module. If you have not gone through this, this is a full module. All the videos are already live on this channel, and there's a lot of videos on here. So what is networking, intro to LAN, OSI model, packets and frames, extending your network, etc. And actually, apparently, they added a new chunk to the OSI model because I used to be at 100%, but now I'm not. So I got to go ahead and finish that real quick. And in the Linux fundamentals room, because we're going to be using an Ubuntu Linux machine, and the Linux fundamentals videos are already on this channel as well. So you can look for Linux fundamentals and you'll find them. And I literally teach you everything that you need to know for the Linux interface. At the very least, the command line and how to navigate the command line inside of Linux. And if you really want to learn more about Linux and kind of master it, there's the Linux Plus training series that's also available on this channel, the CompTIA Linux Plus. And then I'm going to be launching the Linux Plus for 2026, the new version of the exam that came out just recently. So all of that stuff is going to be available to you as well. So there's a lot of good stuff on the channel to help you prepare for this exercise and for this video today. And if you have not gone through them, or if you want to kind of brush up on all the foundational stuff, then go ahead and watch those and we'll run it. So really, the big things that you need are the command line functions of Linux, as well as the network fundamentals like ports, protocols, and traffic data, blah, 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 yada. So that's it for that intro. The interactive material and the virtual machine. So this is actually kind of like a pretty deep dive on the launch. So once I click on start machine, it's going to actually launch the machine. There's a lot of interactive material here. So we have the subfolders And this is obviously for the specific room that we're in inside of TryHackMe. So unfortunately, if you're doing this on your own machine, you have to find your own examples and sample files and things like that. So the configuration sample is the sample configuration rule and files. They were provided to show what the configuration files look like. The installed Snort instance doesn't use them, so feel free to practice and modify them. And Snort's original base files are located under the etc Snort. So we can actually use the configuration files in here when we run Snort instead of the default configuration files that come with the Snort installation. And then we have our exercise files, basically separate folders for each task. It contains a PCAP, log, and rule files that are ready for us to reference, and so we can see that right here. And then there's a traffic generator script, which is very crazy because the machine is offline, but we need to generate traffic. So that's why they have the script for us to generate the traffic on the Snort interface. And we'll use this to trigger traffic to the Snort interface. Once you run the script, it will also ask you to choose the exercise type and then automatically open another terminal to show the output of the selected action. So note that each traffic flow is designed for a specific exercise. Make sure that you start the Snort instance and wait until the end of the script execution. Don't stop the traffic flow unless you choose the wrong exercise. So you run the generation sh file by executing it as sudo general desktop overview. So this is kind of what it looks like if you were to run it like that. So when you actually run it, it'll show the traffic generator window right here. You choose the one that you want to do for the exercise that we're working on, and then it'll open up a terminal and run through it. Once you choose the action, the menu disappears and terminal instance opens up as showing you output, which is what you see right here. So this will be the output of the Snort rules, right? So these are, if you aren't familiar with it, actually, I don't think this is the output of the Snort rules. I think this is just the traffic generator, and then we would need to have Snort running in the background to be able to detect the various traffic based on the rules themselves. So that's pretty much it. So it says navigate to the task and run the command easysh and write the output. So okay, so that requires that I actually launch the machine. So we're going to do this, and it's going to give me a warning because I'm super zoomed in. And then it's going to look at that super zoomed in. So we're going to give that a quick second, and it will go run that easysh command. All right, cool. Our machine is up and running. So let's open up our terminal here and let's see where we are. So print working directory, we are here. If we look at our stuff, it's on the desktop. So let's go to the desktop and let's go to task exercises, and where traffic generator, where's the script? So the easysh to write the output. So easysh to write the output. Is it inside of here? It is. It's hidden. Look at that. So the dot that shows right there, that means that it's a hidden file. So the way that you run scripts inside of Linux is by just doing a dot to reference your current directory, then you do a /, and then you do the name of the script. So in this case, we also need to have to use the dot in the name, and then we'll do easy.sh like that. So when you do that, and then the answer is too easy. So that's basically it. All right, so they just wanted to test to see if we can actually write the script or run the script. So, all right, there's that. Solid. So now let's talk about the introduction to IDS and IPS. So I'm really not going to go into a deep dive on this because we've talked about this very frequently. And even if you aren't familiar with these concepts, it's going to be very, very easy for you to wrap your head around them. So an intrusion detection system, as the name implies, it is designed to detect intrusions. Okay, so let's say that you have a firewall. Let's see if we have a graphic for this or anything like that. We don't. But okay, so if you can imagine a firewall, its job is basically to allow traffic into the network, right? So there are rules in place. The firewall says you're allowed to go in, you're not allowed to go in, etc. Any traffic that gets past the firewall is an intruder, right? So if it's not supposed to enter and it gets in anyway, it's considered an intruder. And so the job of an intrusion detection system is to detect the intrusion, right? And that's basically it. And then from there, it's up to the analyst, the security analyst, to do something about it, because it'll generate an alert for us, and then it's our job as the analyst to respond to those alerts, right? That's an intrusion detection system. It just detects and alerts, and it does nothing else. Intrusion prevention system, actually takes action on something. So let's say that you want to drop the connection and then you want to block a certain IP address. That's what a prevention system does. So kind of reading through this, again, I'm just kind of gonna gloss over it, right? So we also talked about this in the very last episode. So intrusion detection systems come in two formats. We have the network intrusion detection system that is assigned to the entire network and all of the devices in the network. And then there's the host-based intrusion detection that is just assigned to a specific host. So if you think about it, in the network, there's going to be, sometimes thousands of hosts. And so it's very difficult and it becomes very overwhelming to have a host-based intrusion detection system on every single one of those 1,000 hosts. And then the analyst has to monitor 1,000 different inputs, right? They have to monitor 1,000 different interfaces. Where when you look at the network version, they just monitor one certain interface, but within that one monitoring, they get access to all of the data that's coming from those 1,000 different host-based IDSs, right? Or those 1,000 different hosts, I should say. So the question is like, okay, well, why would there even be a host-based if there is no, if you can just use the network? And that's a great question. And sometimes you have 3 devices inside of the network and you want to look at all of the details of all of those devices on a granular level, which is why a host base was created, because sometimes you really do want to see everything that goes on in a given host instead of just looking at the network at large. So a network looks at all the devices, all the hosts inside of a network. The host base just looks at that one host, right? That's basically it. The intrusion prevention system is active protection for preventing possible malicious activities, abnormal incidents, policy violations, and is responsible for stopping, preventing, or terminating the suspicious event as soon as it's detected. So instead of generating an alert, it'll actually do something on your behalf as soon as it detects something. And then it'll create an alert and it'll say, hey, this is what I detected, and then this is what I did about it. So it's similar to what we looked at with the intrusion detection. There's actually intrusion prevention on the network level. So it looks at intrusion prevention on the network level, all the traffic from the various areas of the network to protect the traffic on the entire subnet. If its signature is identified, the connection is terminated. And then there's behavior-based intrusion prevention, which is network behavior analysis, which systems monitor that the traffic that flow from various areas of the network, and the aim is to protect the traffic on the entire subnet. If an anomaly is identified, the connection is terminated. So the anomaly part of it is very important. So most often than not, there's going to be signature detection, which is like a giant database of signatures, a giant database of, call them like an identifier, right? That identifier, if the IDS or the IPS notices that identifier entering the network, just because it matches the database, right? It matches something inside the database. They're like, oh, I know this is malicious. We're going to block it immediately. Behavior-based isn't really that hard set rules, because a lot of times hackers will actually develop something brand new. It's called a 0-day. And so a 0-day exploit is not inside of a database because there's never been a detection about it. Nobody knows about it. And so we now need to watch the normal behavior of our network, also known as the baseline. And then if we actually notice anything that deviates from that baseline, that would be considered an anomaly. And so that's when the trigger goes off and the alert is generated, or the IPS will block certain activities from taking place, because it's like, okay, well, this is outside of the baseline behavior. I think this is an intrusion. Now, this can actually also yield a lot of false positives, because behavior-based analysis can see something that could just have been an honest mistake, or it could have been something that somebody did wrong, but they weren't actually trying to hack us, right? So something like that, and then it'll be like, oh, this is a red flag. I'm going to go ahead and block this. So it generates a bunch of false positives. So that's one of the things that with behavior-based systems, we have to constantly be tweaking and optimizing so that it gets more honed in on what the baseline actually is, so that it really does detect something that is actually malicious instead of generating a bunch of false positives. The network behavior analysis system works similar to the network intrusion prevention system. And the difference between the two is that behavior-based systems require a training period, also known as baselining, to learn the normal traffic and differentiate the malicious traffic. This model provides more efficient results against new unknown threats, but it's more resource intensive and it takes longer. The system is trained to know the normal and to detect the abnormal. The training period is crucial to avoid false positives. If there's a security breach during the training period, the results will be highly problematic. Another critical point is to ensure that the system is well trained to recognize benign activities, which is again why we have optimization going on. Then we have the wireless intrusion prevention system, also known as the WIPS, which monitors the traffic from a wireless network. Its aim is to protect wireless traffic and stop possible attacks. This one's kind of basic to understand. And then we have the host-based intrusion prevention system, which is very similar to the host-based intrusion detection system, except this one actually prevents activities from going further. So detection and prevention techniques. So we have I already kind of touched on this a little bit. So the technique itself could be a signature-based, which relies on the rules that identify specific patterns of known malicious behavior. This helps to detect known threats, and this requires that we have a really big database of known behavior or known signatures. And so anytime something happens, it gets compared against that database, and if any of the signatures match, it's like, boom, I already know that this is malicious. I'm going to block this from going forward. Behavior-based is not so hard and set in its rules. It identifies new threats with new patterns that pass through signatures, and the model compares known or normal behaviors with unknown or abnormal behaviors. So it compares the baseline against anomalies, which helps detect previously unknown or new threats. And then we have policy-based, which compares detected activities with system configurations and security policies, which helps detect policy violations. So, in summary, the IDS can identify threats, but it requires user assistance to stop them. It just detects the threat and it gives an alert. An IPS can identify and block the threats with less user assistance at the time of the detection, but it'll still generate a report, which is nice, so that you can go ahead and review what just happened. So, how does Snort come into play, knowing all of this? So the rest of the official description is available on their website, obviously, if you wanted to. I think it's called Snort. Or, well, who's the company that started Snort? I want to say, no, Portswigger is Burp Suite, I think. Yeah, Burp Suite is Portswigger. So Snort is probably a different company that I'm now getting confused. But the Snort website, there's the full description of what it is and what you can do and how you can download it, all that stuff. So let's look at the description here. It says it can be deployed inline to stop these packets as well. Snort has 3 primary uses: packet sniffer, packet logger, and then the network intrusion detection system or intrusion prevention system. It can be downloaded and configured for personal and business uses alike. It's open source, rule-based network intrusion detection prevention system. It was developed and maintained by Martin Roche. Open source contributors like the Cisco Talos team as everybody else. So there we go. If you want to read through all of these, you can go ahead and read through that. I'll give you a couple of seconds. 1, 2, 3, moving forward. The modes are important. So we have sniffer mode, which basically is like TCP dump or Wireshark capture. Packet logger mode, which logs all of the IP packets inbound and outbound, and it generates a packet, a PCAP file for you. And then the NIDS and the NIPS mode, which are basically where the security mechanisms of Snort come in, where they can actually log or drop the packets that are deemed malicious according to the rules that we have defined inside of our configuration files. So, which IDS or IPS type can help you stop the threats on a local machine? This would be a host-based. The answer is incorrect. Okay. Why is the answer? Oh, you know what? HIPS like that. That's what they're looking for. Got it. Which IDS or IPS type can help you detect threats on a local network? That would be a NIDS or a NIPS, right? Which IDS or IPS can help you detect the threats on a local machine? I mean, I guess same thing, or NIPS. No, I'm sorry, HIPS. HIPS or HIDS. There we go, HIDS or HIPS. It's the same question. Can help you stop threats on a local network. So stop threats on a local network, that would be a NIPS. It helps you stop it, right? Which described solution works by detecting anomalies in the network. And so that would be IPS. Which described solution works by detecting detecting anomalies in the network? What the heck is going on? Why is that? How am I missing this? It's literally it, right? So IDS or IPS were the answers. So what exactly are we missing here? Block threats, okay. Anomalies, okay. What am I missing here, buddy? I see. So it's the network-based behavior analysis. I believe this is the one. So NBA, not to be confused with the National Basketball Association. According to the official description of the Snort, what kind of NIPS is it? I want to say that it's signature, right? Signature based? Nope. Anomaly? No. Okay, what kind of NIPS is it? According to the official description. So let's go over here. Let's see. It can be da-da-da-da. Snort can be downloaded, okay. Full-blown network intrusion prevention system. So full-blown, I guess. Is it a full-blown? Is that the description? Debugging can be used for full. I wonder if that's the actual answer. That'd be so stupid if that's the answer. It is the answer, isn't it? That's crazy. Okay, NBA training period is also known as the. That's a good question as well. So where is it at? Let's go and find the NBA portion real quick, buddy. And it is known as the. Where is it? Oh, I see. The baselining. It's known as the baselining period. Very good. All right. Boom. Nice. Okay, so let's go and do our first interaction with Snort. So first we want to verify that it's actually installed, and you can just do this by running the V command with Snort, and it'll just give you the version of Snort. And if you get an output, that means that it's installed. If you don't get an output, that means it's not installed. I love this little thing right here, this little piggy that they created using the punctuations. That is genius. I love it so much. But okay, so this is how we can find out whether or not it's installed. And we should ensure the configuration file is also valid. So this is where the -T is used to test the configuration, and -C identifies. This is not how you spell identifies. That is hilarious. Like clearly this was not the first language of the person. I mean, no disrespect, the most amount of love. Thank you so much for doing it, but that is hilarious. It identifies the configuration file, snort.configuration. It's possible to use an additional configuration file by pointing to it with the -C, which is what we're going to end up doing. So this is what it is, right? So you run it, and then you do -C, and then you give it the path to the configuration file, and then you just do -T at the very end with a capital T to test it. So initialize output plugin and it'll actually go ahead and run it for us. So once we use it, Snort has much more power when you use a configuration file. It's the all-in-one management file. There's rules, plugins, detection mechanisms, default actions, and output settings identified. You can also go ahead inside of your rules right there, or the configurations. You can say, you know, this is my subnet, right? And then when you assign a subnet to it, you can then give it the variable of home net or something like that, whatever the name of the variable would be. And then you can use that inside of your rules. So that way, instead of having to do a bunch of different IP addresses or subnet addresses, you can assign it once inside of your configuration file. And then with your rules, you can literally just give it the environment variable instead of listing every IP address that would be inside of that environment. Snort automatically shows the default banner and initial formation about the setup when you started. You can prevent this by doing the -Q, which is, I refer to it as quiet. So -V, capital V, or the -- version would give us the version. -C is what we use for a configuration file. -capital T is the self-test parameter. And -Q is the quiet mode that prevents Snort from displaying the default browser. So easy stuff. So we're actually going to run it now and see what we got. So it says check the build number. So that's going to be with our -V. So let's see what we got for the build number. It's build 149. And we got our little piggy right here. I love that little piggy. Okay, cool. So build 149 is what we got. Test the current instance with the Snort configuration file and check how many rules are loaded with the current build. So we're going to basically run this command right here. And so we're going to use the current configuration file. So we do have to use sudo. So we're going to do sudo snort-c, and then we're going to give it the etc snort configuration file. And then at the very end, we're going to do a -T like that, just to make sure that we run it in test mode. So we're going to press enter here. Okay, that's a lot of stuff. I hope it gives me a count because, okay, cool. So now I need to know how many files were loaded. This is the piece that I'm like, okay, well, patterns, match lists. Let's see, what's the answer that it's looking for? It's looking for the how many rules are loaded. So let's see how many rules are loaded. Okay, so there are a couple of numbers here that might be the answer. So we have 4151 rules read, and then we have 3477 detection rules. And so does it say detection rules? No. So 4151, I want to say, is the answer. Very good. Test the current instance with the snort v2 configuration file and check how many rules are loaded with that instance. So I'm basically just going to press up on my keyboard, and it's going to load the last command, and then all I need to do is just change the configuration file to snort, what is it, v2, like that, and that's it. Okay, that was fast. That was much faster than the other one. So if we run that, and if we scroll to the top, it says 1 rule read. So that's basically it. That's all we got. Cool. All right, so let's go into sniffer mode. Okay, so for this specific section, there is no actual question to answer in the end. And instead of just reading through everything and then applying it, I'm gonna just apply it as each section that we go by. So just to kind of get a little bit more practice under our thumbs here. So in sniffer mode, you can use V for verbose, which I feel like you should every time, no matter what you're doing, no matter what command line tool you're using. I always try to default to using V just to get more information. -D would be displaying the packet data, also known as the payload. -E would give us the link layer headers. -X will give the full packet details in hexadecimal, and -I helps us define a specific interface to listen to or to sniff. If you have multiple interfaces, you can choose a specific interface to sniff. That's basically kind of what it is. So using each one of these and see the difference between them, Snort needs active traffic on the interface, so we need to generate traffic in the Snort. To do this, use the traffic generator script and sniffing with parameter I. So I'm guessing that we would need to start sniffing first, and then we would turn on the traffic generator. I think that's kind of what it's supposed to do, because it's running, right? It's like it needs to be running in sniffing mode. So start snort in verbose mode, use the interface I, and then in case you have one and then do the traffic generator, I think. So that's basically what it is. So we're going to zoom out here. I have snort in this terminal, so I'm just going to clear my terminal and have that ready to go. And then I need to go ahead and access the traffic file. So let's open this thing real quick, and we'll put this right here. We'll go to File Manager. We will do the traffic generator sh. So there's that, and there it is. So what do I? Oh, I see. I'm sorry. I'm supposed to actually do this in 2 different instances, I think. So we're going to do this. There we go. So this one will end up being traffic generator sh. Or which one? Yeah, this one. That's fine. So we'll go into the desktop and then go into task exercises, and there is traffic generator. So traffic generator.sh like that. So again, remember, you got to do the /traffic generator.sh, press enter, and there's the script. Okay, so I don't really need to do anything because we haven't gone into ICMP yet, I don't think. I think we're just testing it. So we'll see, I guess. I don't know exactly, but it hasn't mentioned anything that specific type of traffic generation. So we're just going to kind of do normal traffic generate. I'm just going to do ICMP. It has HTTP task 6, 7, 10, and then there's 2 different exercises for 10. So I'm just going to do ICMP for that. And I'm going to move this to the side here. So first we want to run sudo in snort mode, or what am I saying? Snort in sudo mode. Yo, today's dyslexia is going really strong. I've been recording a bunch of videos, so my brain is like just all over the place. Okay, so there we go. So we're going to run snort in sudo mode, And there it is. It's actually running. And there you go. All the headers and everything are running. Nothing is going on. So let's see if we generate. I mean, I don't need to do anything. It's like literally generating everything in the background. And this is what verbose mode looks like, right? So this is basically what it is. And if I wanted to, so it says now run the traffic generator, okay, and start ICMP or HTTP. Once the traffic is generated, Snort will start showing the packets in verbosity mode as follows. I haven't done anything and it's already doing it. So let's actually run the traffic generator and see what we see. So now we get to see, do we see anything that's interesting? So it says packet processing PID. It's just capturing these things. It's kind of basically what it's doing. So nothing exciting. Traffic generator is working. So it says unable to create directory for yada yada, permission denied. Okay. Was I supposed to do it in sudo mode or something? To terminate the options and put the command. It doesn't seem like it. It seems like it doesn't seem like I need to do anything because it's literally, I feel like it's working. So I'm just going to stop this. There we go. It started or stopped and it detected all these things for us. So IPv4. All discard. Let's see if we have anything for ICMP because I did the ICMP one. It detected no ICMP traffic, which means that this did not actually work. So error creating child process for this, failed to execute child process, no file or directory. Okay, so this is an issue. So let me see if I can do a sudo and then do the traffic generator. See if that works. Okay, ICMP traffic. So let's do this one more time. And let's see if we can actually generate any kind of ICMP traffic because we need this in order for it to work. There you go. Okay, so we needed to do it with sudo because it said we didn't have permissions. So now it's actually generating traffic and we can see that there's no issues with the errors that we got. And the traffic is now finished generating. So now we can go here and stop this. And if we go up to ICMP, we now should have traffic. So there we go, 68 ICMP packets. Excellent. So it actually worked. Great. Okay, so now sniffing with D, which is the dumping packet data mode. Generate the traffic generator, da 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 da. See, now it says generated as sudo because in the previous one, it didn't say, oh, it did say as sudo, but it wasn't highlighted. So I didn't notice it. Okay. Start ICMP. Once the traffic is generated, Snort will start showing the packets, whatever as follows. Okay, great. And that's basically it. So given the output, the packet data payload mode, I see because it's supposed to be generating the payload for us, right? So -D up here said displays the payload. Okay, great. So we can see right here, it didn't display payload data, I guess. It's just showing the traffic itself. It's not giving us like a full payload. So maybe we can now get, for the ICMP traffic, maybe we can get payload data by using the -D. So we'll do sudo snort -D. Before I do that, let's go ahead and run the traffic generator one more time. Or actually, no, I'm sorry. Let's press enter on this, and then we're going to go and run the traffic generator one more time. And then we're going to do ICMP traffic. Oh, you can already see that the payloads, you can see there's way more data that's actually being generated. You can see the bits, right? You can see all the hex stuff. Yeah, all that stuff is actually being generated. So we can actually see the payloads. So let's go ahead and stop it. And let's scroll up. Again, 68 packets for ICMP. But if we go up here, now we actually see some extra bits right here. You see these bits? All of that stuff is useful to us. And then we can also see this is the hexadecimal version of the bits. Or yeah, I think this is hex, right? Or this would be ASCII and this is hex, I think. But essentially it's showing us the payload. You can actually see the payload going on. Let's see, where's the other ones? There we go. So you can actually see the payloads going on right here as well. So some of them don't have it, and then some of them definitely do have it, and you can see it. It's mostly these bits right here. Some of them are more obvious than the other ones, but it's these bits that you see at the bottom right here. You see this one's definitely more obvious. This one didn't have it. This one has one line. This one doesn't have it. This one has several lines, so this is the most obvious. Okay, so those are our payloads. And then we got the -DE. So you can also do -DE together or separate them by doing -D and then -E. So D would be for the dump, and then E would be the link layer header grabbing. So you can do that, and then we could do the same thing with our traffic generator. So we can just go and do up it'll do -D for the snort command, but I'm just going to do a -E at the end, or just add an E. Very good. And then press enter, and then go over here, go over there, press enter on that, do ICMP traffic, go like that. And let's go look at the headers that are generated. So we can we see headers? What exactly would a header even look like in this case? What am I comparing this to? I don't even know what I'm comparing it to. So let's end that. So what is it? If we look at the examples here, we might be able to see. So commencing packet processing. Okay, we got that. What's the difference? Packet processing. I guess these are the headers. The link layer header. I guess, bro. I don't really see a difference, but I guess we'll just say that there's a difference, right? I don't see that much of a difference. So the key difference, because this one, processors okay, timestamp okay, the traffic direction okay, same thing, timestamp, traffic generation. There is, oh, you know what? I do see a MAC address. It seems like there's a MAC address here. Link layer header grabbing. Yep, for sure. That's exactly what it is. Because now I see a MAC address here, and I also see a MAC address here. That's what it is. The link layer shows us the MAC addresses. So they're talking about the OSI model link layer header grabbing. Okay, cool. So if we wanted to see MAC addresses, we can do the -E. And then we have with parameter X to give us the, what is this going to give us? Full packet dump mode, -X, which will give us probably a bunch of stuff. So let's do -X here, press enter, and let's see. Yeah, you can already see what's going on. So there's a bunch of crazy stuff. I'm not going to run the traffic generator because you can literally see it. There's a lot of stuff. Actually, the payload stuff for these is significantly more robust, it seems, because you can actually see much larger payloads, as you can see right here. I wonder if it's because like these are just the general traffic that's being generated and we didn't do the pings, because the pings would have significant smaller payloads because we're not generating anything really. We're just sending a ping. But I mean, these are significantly bigger. And then you can see that we have the, we don't have, interesting. So we don't have the MAC addresses. So let's do that again. I want to see if it's because maybe the MAC addresses were only reserved for our pings that we were doing. So let's do that. And then we'll do ICMP traffic, do that. And let's go here. Let's see if we're getting MAC addresses on this. I mean, the traffic is significantly more robust. You could just see that the traffic is more robust and the binary and the hex stuff is more robust. But if we just go up here, do we see MAC addresses? We do not see MAC addresses on these. Okay, so I guess the hexadecimal, or not hexadecimal, just the X version, which is full packet dump mode, I guess that version doesn't give us the headers, the link layer headers. So that's basically it. We just had some examples of running Snort. We ran it with verbose. We could do verbose with the dump. We could do dump and the link layer. We could also do it separate like that, and then we can do the full dump version as well. So hopefully we can kind of understand what these things are so that as we move forward, we can get more data and answer the rest of our questions. So let's go into operation mode 2. So the first one was operation mode sniffer mode. Now we're going to do packet logger mode. Okay, for this mode, we actually have a bunch of questions that we need to answer at the very, very end. So, you know, the options are here. The parameters -L would be in log and alert output directory, and we just need to give it an output directory. So it would end up being more often than not the log directory for Snort, which is fine. Default action is to dump it as TCP dump format in Snort directory. -K ASCII logs packets in ASCII format. -R reads things, reads the whatever we have inside of a PCAP file, and we need to give it a path to actually read. So if we use this, we do need to give it a path. And then -N specifies the number of packets to be processed or read. It will stop after reading the number of packets. So before generating logs and investigating them, we have to remember the Linux file ownership and permissions. There's no need to delve deep into user types and permissions. Snort needs super user or sudo rights, so we got to use it with sudo. They should have said this at the very beginning. I don't know why they're saying this now. So we will need root rights to investigate the log files, which is also known as just using sudo. So sudo chown username file or sudo chown username r directory. So elevation of privileges, you can do that if you want to just go ahead and change the ownership, I guess, or you can just do sudo at the beginning of everything. I don't know if we need to do that. Changing the ownership of files and directories. Should I do this? I don't know, bro. Okay, so what I'm going to do is this, right? I'm going to go ahead and just change the permissions of a few different things for us, just so we actually have the sudo change owner permissions. I don't know why the hell we're doing this, but sudo chown, right? And then we're going to do, I guess, root as the user, and then give it the R and then the directory, which was the task-exercises. I'll do that. So failed to open directory task exercises. Okay, well, I don't know why the hell you're making me do this if that's not, okay. You know what, bro? I'm going to skip that part. We're just going to use sudo at the beginning of everything. Who cares? Okay, so logging with the parameter. So we're going to reverse engineer this, really, honestly, because I want to be able to find all these answers, and I don't want to read through everything before we can start doing the exercises. So it says investigate the traffic with the default configuration file with ASCII mode. So sudo snort dev ASCII, okay? And then execute the traffic generator and choose task 6 exercise. Wait until the traffic ends, then stop the snort instance. Now analyze the output summary and answer the question. And then, okay, so this is the next step of this. Now you should have the logs in the current directory. Navigate the folder for this. And what is the source port used to connect to 453? Okay, so we're going to run it with this command. It literally tells us to run it with the current command, and it's going to have the output be inside of our current directory. So that's great. We're going to be running it with ASCII mode as a developer. It seems like, I don't know what the DEV, oh no, I'm sorry. It's going to be a dump. It's going to give us link layer, and then it's going to give us verbose output. That's what that is. So these are the flags. So we're going to do a data dump with the link layer header as well as a verbose output, and then we're going to give ourselves the output of ASCII, and then we're going to have it be done inside of our current directory. And then we're going to run the traffic generator, and we're going to generate which traffic? Task 6 exercise. Okay, so here we go. Sudo snort -dev -K ASCII, like that, -L, and then give it a local location. Actually, so you know what? I'm sorry. Let me just skip all of that. We're just going to clear that. We're going to go back into the task exercises. Oh my God, I just changed the permission. So sudo cd task exercises, and the command is not found. I think I just made a really big mistake, because when I did that sudo change ownership, it now is giving me an issue and I can't access task exercises. How crazy is that, bro? So sudo chown, and then let's do, what is it? Ubuntu will be the user. I can't believe I just did that, dude. Let's see if this changes things, and now we can go back into task exercises. Okay, there you go. Holy cow. So it did work. So, okay, so what happened was I changed the ownership of the task exercises to the root user, and now I wasn't able to do it, so I just changed the ownership of the task exercises to the Ubuntu user, and now I can actually go into the okay, all right. We didn't really need to do that. I don't know why the hell it made us do that, honestly. Whatever. Okay, cool. Okay, so now we're gonna do inside of this location, we're gonna run sudo snort with the dev-k, and we're gonna do the ASCII-L dot. So it's gonna run it with the dump data link layer verbose. It's going to give us output of ASCII format, and it's gonna enter it in our current directories where it's gonna output it for us. So I'm gonna do that, and then we're gonna run the traffic generator in the next command right here. So we'll go right here, do the traffic generator, press enter. We're gonna do task 6 exercise, okay. And there we go, it's running, everything's all good. And it says now you should have the logs navigate to the folder, What is the source port used to that? Okay, so we're done with that. Excellent, the traffic is done. Let's end that. And so we should have now a new folder here. And we do, look at that, we have a bunch of folders, cool. So we're looking for the 162.37. So it's this one right here. Let me see if I can just copy this instead of doing that whole thing. Copy that. Let me go into this location. Sweet. Permission denied. Wonderful. Of course, permission is denied. Sudo change owner to Ubuntu, and then give me that specific folder. Maybe that's why they wanted us to do it. Okay, so now I should be able to go into that folder. There we go. All right. Okay, so the scan now is what? It says, what is the source port used to connect to port 53? So it is 3009. It's a UDP connection. So 3009. Okay, well, now it makes sense. Now it makes sense why they made us want to do the change ownership and stuff like that. Okay, cool. So, all right, next one. Use the log read the snort log file with snort. What is the IP ID of the 10th packet? So this is the log file that we're going to be reading. Where would that be located? That's the key piece that I'm like, okay, well, so if I'm reading TCP dump log file, snort log, where are the logs? I don't understand. Configuration samples, log files. Are they in the I think they're in the Verilog snort folder, right? So, okay, so if I go ahead and, so what do we do? We're going to do a read, or let me do an ls of the Verilog snort folder, and there's nothing there, so that can't be the place. And there is no packet, no IP, traffic generated, exercise files. Would it be in the exercise files? Task 6, is that what we're on? What task are we on? We're on task 6, so let's go to task 6 here. CD task 6. And is there, okay, there it is. Okay, got it. So in the task 6 folder, we actually have the log file. Okay, so now it says, read the snort log file with snort. What is the IP of the packet? So this is to use the read functionality of snort. So if we actually go up here, we can see, so they showed us right here, basically what it would be like to capture the packets, excuse me. It showed us what it would be like to capture the packets, and then it showed us what it would be like to read the contents of it, which is what these IP addresses and these things are that you see right here. Okay, so that was the first portion of these commands right here. It's actually logging with the parameter KASCII. Okay, so all of those things, solid. So now the next piece, and this is what it looks like in the folder view, because we already saw that as well, and we needed to give ourselves permission to be able to read it, and then we saw the responses right here. So all of these things, great, okay? So reading the generated logs with the parameter R, which is what we're going to be doing now. So as long as we know where the log file is, we can read it. So in this particular case, the one that we want to read, hopefully because it's in task 6, is this piece right here. And so we can see that when you read it, this is what it looks like, and it reads the log file for you, and it shows you all the entries and things like that. You can also open it with TCP dump to actually see what's inside of it and do a variety of different flags using TCP dump, right? So it says Snort can read and handle binary log output. TCP and Wireshark can also do this. However, if you create logs with this parameter, Snort will not read them. As you see in the output above, which is, I guess, what we see right here, Snort read and displayed the log file just as it does in Sniffer mode. So opening it with TCP dump using the count of 10 lines, so I think it's just giving us 10 lines here, the same log file, and so it read it for us, and then you can see that it actually has everything that it would need. So opening it with Wireshark would also read it for us. So no issue. It's a log file. It shouldn't be an issue that we would be able to, or we wouldn't be able to do. So the R parameter allows us to filter the binary log files. You can filter the process log to see specific packets with the parameter, with the Berkeley packet filters. So you would read it and then give it a variety of different parameters. So for example, I wanted to see all the hex stuff. I want to see only ICMP packets. I want to see only TCP packets. I want UDP and port 53 packets to show up. So this will be the same as above, but only packets with the chosen protocol will be shown. Additionally, you can specify the number of processes using the n parameter, which we already saw. Oh, that's actually it. So that's all the stuff that they actually had for us to read. So, okay, that's cool. That's easy to go through. So now it says read this, which is, I believe, the one that's here. Perfect. Okay, great. What is the IP of the 10th packet? So the IP ID of the 10th packet. So we're going to do snort-r, and then we're going to give it this snort.log file. Very good. By the way, this is a really good trick if you're not familiar with Linux. As long as you type the first portion of something inside of a folder and then you press tab, it'll fill the rest of it in for you. So that's a cool little hack right there. And then so we want the 10th packet, so we're going to do the -n and then just the number 10 to read 10 lines. So let's go up here and read the 10 lines. So the 10th one would be this one right here, right? So we're looking for the IP ID. So IP ID is 49313, I think, right? So IP length, yeah, 49313. So let's try that, 49313. Solid. Okay, so read the packet with Snort. So same log file. What is the referrer of the 4th packet? So we do the same thing, right? Same exact command, except now instead of reading 10 lines, we're going to read 4 lines. So we're going to go up, find the last one, which is this one right here. And then we're looking for the referrer. So no predecessor found for this. Which one is the referrer? Referrer. I think I'm definitely missing data for this. So we're going to see, I think, what's the hint says? Okay, -x. So we got to do the same exact thing, actually. We're just going to do -x to get the most information for each one. So let's see if that actually, there we go. We actually got a bunch of data. Okay, so we want the referrer, which is this guy, http ethereal.com/development.html. And so I got to go ahead and actually type that out. So www.ethereal.com development.html. Perfect. All right, so read the log again with Snort. What is the ACK number of the 8th packet? So let's now do the same thing, and I'm just gonna keep it with the X option, but let's see what the 8th packet gives us. So if we go over here, we want the acknowledgement number. This is the 8th packet, massive freaking packet, holy cow. Okay, so the ACK number right here, this is the ACK number. That one's a little bit more straightforward. So we're gonna copy that one. Cool. And read the file. What is the number of the TCP port 80 packets? So we want to look at TCP port 80. So what was it? TCP and port 80. So the number of the TCP port packets. So we want TCP and port 80. So we're going to read the full thing. Let's go back in here. We're going to read the full thing. We want TCP and port 80. That's the thing that I'm most interested in. So we're going to do something like TCP and port 80, like that. Hopefully that's, come on, that's the command, right? So it reads it. Total of 41 is what we got. Boom. Look at that. That's it. That's how it works. Nicely done. So we just ran this command, right? So literally read it with Snort. So Snort read, gave it the name of the log file, and then we just put inside of this little quotation TCP and port 80. Very similar to what they showed us over here. UDP and port 53, we just did TCP and port 80. And wham, bam, thank you, ma'am. We got our answer. So beautiful. Let's go to operation mode 3 as an intrusion detection and intrusion protection mode. So this one is a little bit more robust of a task, and so I don't want to skip through too many things. So IDS and IPS mode depends on the rules and configurations. Task 10 summarizes the essential paths. Also, task 3 covers configuration testing. First, we need to understand the operating logic, then we'll proceed with task 9. So I don't know why the hell we just did all that. So task 3 was the configuration testing. We already did that, right? The -T. So we're going to talk in the next task about summarizing essential paths, etc. So right now, we're going to look to the rules, right? Because that's where we are. No, we're not even there. So we're in task 7. So I don't know why why would you do this? Okay, cool. Snort in IDS IPS mode. So -C defines the configuration file, -T is testing, -N disable logging, -D background mode, -A are the alert modes. So if you do -A console, it actually reads everything onto the console. CMG is basic header details with payload and hex and text format, and -A none disables any alerting. And I don't know if we want that really, but for now, let's kind of look at everything that we want. So if you don't already know, because you didn't review the last video, there are rules that are inside of our rule file. So we can go ahead and look at the rules that would be available to us by going to the etc configurations file for Snort and then looking at the rule file. So in our location is right here, Snort rules and then local rules. So before we move forward, let's actually look at the stuff that's available here. So clear this up and let's go to the I'm going to do a nano. We'll do nano etc snort rules local.rules. So this is what the rule file looks like. It just has one rule in it. So it's for detecting pings. Okay, so from any port, from any IP and any port to any of our internal IPs and ports, as long as there's a ping that takes place, it says ICMP packet found, and then that's basically it. That's all the alerts that we're going to get. So if we were to run it in the normal mode that it has, then it would actually alert us, right? So if we ran it in alert mode, it would actually alert us for this, and it would kind of show us that, hey, there's pings going on. Like if I ran it and then I ran the traffic generator as a ping, then it would actually show us that there's pings going on. So that's the basic rule, right? Remember that this will focus on operating modes. The rules are covered in task 9 and 10. So we're going to create an alert file if the traffic flow triggers an alert. One last note, when you run it in IDS IPS mode, sniffing and logging mode will be semi-passive. You can activate the functions using any of the various parameters that we've ran so far. And if you don't remember the purpose of them, please refer to task 4. Wonderful. IDS IPS mode with parameters C and T. So configuration file and testing. So sudo snort, give it a configuration file, right? And then just run it in test format. It'll check the configuration file and prompt you if there's any configurations or if there's any misconfigurations in the current settings. We'll be able to familiar with this because you already reviewed it. I appreciate the fact that at least there's redundancy because he keeps reviewing things that we've already looked at. So that's cool. IDS and IPS mode with -N because we don't want to, show anything, right? So -N will disable logging mode. The rest of the functions will still be available. Output will provide the requested information. If you activate verbosity or any of these things, you will still have the output in the console, but there will be no logs in the log folder. So that's what that does. With -D, capital D, generates a pseudo, etc. Once the traffic is generated, Snort will begin processing packets and accomplish the given task with additional parameters, spawning daemon child, lives, daemon parent exiting. We got that, verbosity and packet capture. You will still have the logs in the logs folder, but there will be no output in the console. Once you start the background mode and want to check the corresponding process, you can use the PS command as we see to see what the current processes that are running and Snort should be running. We can also kill the command by referring to the PID of it, which is in this case 2898. You can also do sudo pkill and then do the name of the command, which would be Snort in this case. Running it with the alert mode, so console, CMG, full, fast, and none. This will actually show the console and CMG parameters, provide great information in the console. It's impossible to distinguish between the remaining alert modes. Differences can be identified by looking at the generated logs. We'll compare full, fast, and none modes. Remember that these parameters don't provide console output, yada, yada, yada. So I feel like these are just kind of, because there's only one question at the very end, and these are just a bunch of different modes that we can use to run our Snort, right? So this was the alert console, which will bring it up on the console, alert CMG, which will kind of bring it up on the terminal as well but the key difference between console fast style alerts, CMG provides basic header details, full alert mode providing all possible information, fast mode shows alert message timestamp and and then none will show nothing. So it says, again, just to reiterate, we'll be comparing these, but these parameters don't provide console output, so we'll continue to identify the differences in the logs. So that's what we got at CMG right here. This is what it looks like. A fast will bring us this mode, so it's not going to be quick, or it's not going to be displayed much onto the screen. It's just going to generate a log. But if we actually look at the alarm file, which is the log file, we'll be able to see something. D-A full will have a similar output, but if you look at the log file, you'll actually see that there is a bunch of alarm with a bunch of details. And then of course, none will not generate any kind of a log file for you. Or there's no alert file, right? There's no alert file, excuse me. There's a log file, but there's no alert file. That's what it is. Using rule file without the configuration file. So you can do sudo snort -c and then just give it the rule file instead of giving it the configuration file, and then have it output onto the screen. IPS mode and dropping packets. So -q and DAQ AF packet. So this is interesting. Is activated with these modes. You can also activate this by editing the Snort configuration file. You don't need to edit the Snort file. In the scope of this room, review the bonus task or Snort manual for further information on the DAQ and advanced configuration strings. The data acquisition, which is DAQ, and the AF packet module to use it as an IPS. That's cool. And then we would have to give it an interface so that it can actually detect it on the interfaces, and it'll actually run as an IPS. That's actually really cool. So identifying the interfaces, it requires at least 2 interfaces to work. The traffic generator run it as sudo and start the ICMP traffic. So sudo snort -c, etc. And then there we go. Okay, there you go. So it gives it the configuration file. Then it would be -q, capital Q, and then data acquisition, AF packet, and then give it the interface, and then all the alerts would be on the console. So we'll see ICMP packet found, but I guess, I don't know if it's going to like stop anything from taking place. Technically, I guess it should, but maybe not. Snort blocked the packets. Oh, I see. So it did block the packet. Oh, yeah, there you go. Drop. So it actually dropped all the packets. Very cool. We use the same rule with different action, drop and reject. Remember the scope of this task. Our point is operating mode, not the rule itself. So now investigate the traffic with the default configuration file. This will be the command. We're going to be using the default configuration file. We're going to get a full output on our alert here. And then the log file is going to be generated in the local location. Execute the traffic generator and choose task 7, exercise, wait until traffic stops. Now analyze the output. That's how we do it. And we want the number of detected HTTP GET methods. Okay. So since we're in task 7, I'm going to actually switch to task 7 just so we can generate our file inside of this location. So inside of this is the log output folder. So that's basically all it is. So we're going to do sudo snort -c, give it the etc snort configuration file. And then we're going to do a full alert -l dot. So this is what the command is. And it's basically what was in the documentation. So sudo snort -c, give it the configuration file, full, and then we're going to log it inside of our current location. Then we're going to go over here and we're going to run our packet generator. We're going to do task 7. Okay, there you go. There's the packets. All that stuff is being generated. Once that is done, we can then terminate. There we go. We can terminate the capture. There you go. Perfect. So it got it. So now it got everything. And now we should actually have a log here. There we go. Okay. So it says, what is the number of detected HTTP GET methods? So we could technically, I think, actually, let's see if we can do a cat of the alert file. And we do. We have that, all these things right here. And so this is a very large file, I'm sure. So what I want is to find the get methods. So I wonder if that's actually is going to be something that we can do by just doing a grep. So if I do a grep of get and then pipe that into the word count by line, it says 0. Okay, so let's do that again, and let's just see if there's anything. There is no get in here. So what if we just do grep of get and then give it the alert file? There's nothing in there. So let's do a cat of the actual log file. So what's the name of the log file? Snort. Okay, so we're going to do a cat of the snort file. Then we're going to grep for get. Is there anything in there? I'm sorry, sudo cat snort. Good lord. And then grep get. Is there anything in there? It doesn't show anything. Okay, so let's do sudo change owner. Give it me the user, and then I want the snort file. Change. Oh, sudo change owner. There is no user called user. Change owner Ubuntu. My God, I'm losing my mind here. We want that to happen. Okay, great. So now I should be able to cat the snort.log file. Oh, I see. Because it can't do it like that. Okay, so it won't work if we just do a cat. So we actually have to do snort-r and give it this snort.log file. There you go. Okay, now I can read this, and now I should be able to grep for get, right? Can I do that? Let's see if we can do that. See if it actually brings up no processor for policy. Okay. Okay, well, that definitely didn't work. So grep doesn't work for this. Let's see what the hint says here. Timing is important. You should start the sniffing before the attack and terminate right after the attack. You can read the provided output statistics summary on the console. Okay, I need to try to figure out exactly what I gotta do to find this, because if nothing else, what we can do is we can just literally open the alert file. So if I go to the desktop here, let's go back to the desktop, task exercises, exercise files, task 7, and now we have our alert file. So if we open the alert file, this is what we see, right? And inside of this, there's a bunch of stuff. So we should be able to actually kind of find through this, right? There should be like a control F. There we go. Control F. So get. There is nothing that says get. There's literally nothing that's in here that says get. So HTTP, there's nothing in there that says HTTP. So what exactly am I looking for here? Because it's not giving me any of the outputs that I'm looking for, and I wasn't supposed to modify anything. I'm just running the packet. So it says execute the traffic generator and choose task 7. Wait until the traffic stops, then stop the snort instance. Now analyze the output summary and answer the questions. Okay. All right. So maybe I missed something in the actual output summary. So maybe that's what it is. So we're going to do this one more time. Let me delete these files real quick. So we're gonna remove the alert file and remove write process regular. Yes, do that. Okay. All right, great. So we're also gonna remove the snort file. Okay. All right, great. So we're gonna do this one more time here. We're gonna run the command real quick, and it's gonna be exactly the same command that it had before. The only difference is I'm going to, instead of doing anything else, I'm just going to look at the output onto the screen, because it said you basically just want to look at the output of the screen. So sudo snort, there we go, configuration. Okay, cool. And then they also said timing is really important. So we're going to do this really fast. I'm going to press enter on here. Then we're going to go here, press up, enter on there. We're going to do task 7. Okay, there you go. Let that finish. As soon as that finishes, we're going to end the capture here. So boom, there you go, and it finished that. Okay, great. Okay, so here's our output. Now we're looking for the get packets. So get methods are 2. Oh, it's literally on the screen. Okay, wonderful. So total number of get methods 2. Very, very simple. Okay, that is actually really, really cool. I thought that it was a much more complicated process, obviously. Okay, so what I want to do is I want to run, because the rest of it is pretty simple. Like we can just basically, generate different outputs and all of that stuff with -a. So literally all of these were just -a commands, that entire section. Up here was just to look at the Snort command itself, the actual running of Snort in IDS mode, and then it would just create any kind of alerts for us. So if I literally do this, so if I do just the alerting version of it, so if we do sudo snort -c and then give it the etc snort configuration file, right? So if we do snort.conf and then just run it just like that, that's basically it. So if we run it just like that, that's kind of all we need to do really, because what we can do is just run the ICMP traffic, because that was the only rule that's there. So if I go ahead and run the traffic generator and do ICMP traffic, now it should get a bunch of stuff in the background, because there's ICMP traffic being generated, but it's not doing that. So that's kind of weird. So let's go ahead and close that out. Did it generate ICMP traffic? That's what I'm curious about. Okay, so it did not. So that's really interesting. Okay, so let's do it with just the rule file, because I said you can also just run it with the rule file, and we would potentially, hopefully, be able to see what the heck is going on, because it should have done it. Oh, you know what? The alert on the console is what I missed. So -a console is what I missed. I think that's what it is. So we're going to run it in IDS mode. There you go. Okay, great. So now if I run this one more time, run that. Come on. Nope. There you go. And then do ICMP traffic. I hope. There you go. Okay, there we go. Now we actually get our alerts coming in. So I forgot the alert portion. It wasn't showing me the alerts because I didn't put the alert portion. So, okay, so that's the alert portion when we're running it in IDS mode. What I want to do is I want to run it in the IPS mode, in the protection version at the very end, that they or prevention protection. So this is the command right here to run it in that mode. So if we do snort, or actually sudo snort, and then do -c, and then give it the configuration file. So this part is very normal. The -q, capital Q, -daq, and then AF packet. These are the modes that we would run for intrusion protection. And then we need to give it our interfaces. So I need to actually do another one just to be able to see our IF config. Okay, so our interfaces, we have ETH1, and then do we have another one? ETH0. So ETH0 and ETH1 are our two interfaces. So we will do ETH0, and then we'll do ETH1, and then A, and then put it on the console. There you go. So there's our intrusion. So, what does it say? Can't initialize DAQ packet, invalid interface specification, ETH0. Why, bro? It's literally my specification. What do you mean? Oh, I see. I didn't do -i. My bad. Okay, so I got to do the -i before I do the interfaces. So that's what it is. So there we go. Now it should be good. And now we're going to run it, and we're going to do the ICMP traffic. Do that. All right. Let's see. What's the action? Are you going to drop it? I mean, it's detecting a bunch of things. So I just want to see if it drops it. Let's see. Okay, packet found. So, okay, where is it? Timestamp here, echo reply, classification, priority 3, miscellaneous activity, ICMP. Where's the drop? I don't have anything that says that it's been dropped. The command right here, I think this is where the drop would be, right? And none of them show that it was dropped. So it's found the packets. It's doing what it's supposed to be doing, but it's not actually dropping the packets. And this is something that I really wanted it to work, because I was hoping I would be able to see it, honestly, because this is the mode in IDS mode that we just saw. It's very similar to what we just saw right here. It's like detecting everything. It has the asterisks inside of the brackets, using the file without a configuration, and then using it. This is for the local rules portion, but then this is the one where we actually use the configuration file in IPS mode, by the way. So it should be at least saying that it's running in IPS mode when we ran it. And it didn't even say that. That's the piece that I'm like, okay, well, this is upsetting. So sudo snort -c, and I did all of that stuff. I did all of those things correctly, but it's not running in IPS mode. And that part is upsetting to me. I don't like that, because it's supposed to give me at least an alert that says it's running in IPS mode. And it's not doing that. And I feel like I'm getting ripped off. But whatever. So we can practice the rest of the parameters by using traffic generator, and we already did all of this. We did the alert that outputted it onto the console. We did the alert that generated a file for us. We can also do we'll just do another one just to kind of do a log file again. So right now there should be no log files. There is actually a log file. So let's go ahead and remove the alert, and let's go and remove the snort file. Remove write protected regular file. So remove snort. Yes. Oh, it actually already did it. Wait, what the heck? Remove snort.log. Yes. Very good. Okay, there you go. So now it's done. Okay, cool. So let's run it one more time. Let's do it with the full command. So we'll run sudo snort -c with the etc configuration file. And let's go ahead and run it with the full output, and we'll go ahead and press enter, and we'll go ahead and run the traffic generator again, and from there it'll generate our traffic. We're not going to get anything onto the screen because it's generating an alert file for us, and it's going to be in full mode, so it should be really exciting. There should be a lot of data in it. So let's go ahead and clear the screen, and let's look at, oh, what the hell, where's the alert file? So if you do it in full mode, to all the possible information, remember there is no console output. Start the instance with the following commands. What the hell? So if there is no console output and there's no alert file, that's kind of or the alarm file, there's nothing. That is actually, again, I feel like I'm being ripped off because I'm supposed to get something. That is really, really upsetting. So we're going to run this one more time. Sudo snort with the configuration file. I'm literally doing exactly what they do here. With the configuration file, and the alert is full. That's it, right? So do I need to do a -L in the current? I shouldn't have to do that because it's supposed to just generate everything for me. Now it actually did it because you just saw the files being generated in the background right there. So now it actually did it. So we should now be getting a log file, and we should also be getting the alert file. So it says check the alarm file. It's not an alarm file, it's an alert file, buddy. Come on, let's be honest. There you go. Okay, so now we actually have the file. Now it's been generating stuff. Okay, I mean, I was hoping that it would work the first time around, but I guess I did something wrong. Maybe I was supposed to do the -L, but I didn't. They didn't do it here, you see? So whatever. Okay. That's basically it. So I mean, the rest of it, you could literally just duplicate the same actions over and over and over again, and it'll just generate new alert files or alarm files for you, and then just provide different types of output for you. That was kind of the biggest piece of this, is that we can either use it in just the intrusion detection and then have the alert be on the console, or we can do it where it actually creates an alarm file or an alert file for us. And then we can even go and establish new rules and things like that to detect other things. So the only thing that we have right now that's being detected is the ICMP pings, because that was the only thing that was inside of our rules file. So hopefully we can maybe create some more rules, because it says snort rule structure down here. So maybe we'll actually kind of do that a little bit. But for now, let's move on to operation mode 4 for the PCAP investigation. Okay, so as we talked about in the very, very beginning, it has PCAP investigation. It can actually read PCAP files. So this is actually one of the cool things about it, because a lot of times you have to do digital forensics and investigations, and reading a PCAP without using any additional parameters is actually not a bad thing. But you can do a bunch of things with Snort to get data. You can extract data from it. So we are investigating the PCAP to benefit from the rules and speed up our investigation process by using the known patterns and threats. We're pretty close to starting to create rules, so it's going to be fun. So we need to understand the working mechanism of Snort to be able to combine it for rules. So parameter -r, and then to read something. So it reads a PCAP file, PCAP list, and then giving it the list of the files inside of the quotations, reads PCAPs provided in command. They are space separated. And then PCAP shows the PCAP name on console during processing. So all of those things are available as well. So investigate a single PCAP with just -r instead of doing PCAP list, right? So you just do snort -r, give it the name of the PCAP. And then we can do it, for example, sudo snort, give it the configuration file, quiet mode, read the PCAP on the console, limit to 10 lines. And so this is what it would look like here. Only the ICMP rule got hit because there doesn't seem to be, it didn't say that we need to do the traffic generator or anything. They didn't mention anything. So it's only, because we don't need to do a traffic generator actually, because we're reading a PCAP file. So that's the reason why. Okay, cool. Investigating multiple with the parameter PCAP list. So you can see right here, they do PCAP list and then give it the name of the PCAPs and then just separate them with a space, as you can see right there. And then it's going to be displayed on the console. So we can see that right here. And then I would also probably do this as well, the PCAP show, so I can know what the difference is with the various outputs that are being on my screen. So ICMP rule got a hit. As you can see, Snort identified traffic and whatever. We're processing 2 PCAPs. There are a lot of alerts, so it's impossible to match them with the provided PCAPs without Snort's help. So we need to separate them to identify using PCAP show. So same thing, sudo snort, configuration file, PCAP lists, and then PCAP show at the very end after the console output. And then you can see reading network from this and then reading network from that. And then the packets have been hit. So that's pretty much it. So now we're going to be looking at the various files to try to get whatever information we can from here. Thankfully, we don't have to read a bunch of things on here because literally we only have one rule that is going to be triggered with this thing. We haven't created any new rules yet. So I'm already inside of the task 8 folder, and we can see that we have HTTP2 PCAP, ICMP test PCAP, MX1, MX2, and MX3 PCAP. So the first one is for MX1, and so we can see that we're also going to generate a log inside of our current folder for MX1, and we're just going to read it using the configuration file, and we're going to do a full alert file, and from there we're going to do the remainder of our question answering. And there's 3 questions dedicated to this first command. So sudo snort -c etc snort.configuration, alert is going to be full, log is going to be in the current folder, -r is going to be the MX-1 PCAP, and voila. So there it goes, and it's going to finish because we don't need to do anything else. Okay, what is the number of generated alerts? So let's go over here and let's see what we can find for our generated alerts. It was up here somewhere. So alerts 0, frag 3 statistics, verdicts allow, okay, alerts 170, so these are the actions, so I think that's probably a good one. What else do we find here? And let me see if there's anything else up here. I think that was pretty much it. I think it was 170, right? Because it's now reading through, and we just went through all this. Okay, so these are detection rules. So it was in the little portion that said alerts. So I just passed it. I think it was 170 though. It's like towards the bottom. Alerts 170. So let's try that. Let's see if that works. Very good. Okay, keep reading the output. How many TCP segments are queued? So if we go to the TCP portion of this, I did see that as well. TCP descriptions, no. Let me see, TCP segments, 41. I believe this is it. So 41 TCP segments. Let's try that. That should be it, not 14, 41. That is not the answer. Okay, so TCP segments is what we're looking for. I think that might be the difference. It's TCP segments. There we go. So TCP segments used are 18. So there's that. Very good. Keep reading the output. How many HTTP response headers were extracted? So let's go and read that. HTTP response headers were 3 of them. So there is that. And great. So now, with the second configuration file is what they want us to do. So investigate the MX1 PCAP file with the second configuration file. So same command, full alert log, all that stuff is the same. We're just using the second PCAP file, or the second configuration file, I'm sorry. So let's see if it generates a new alert file in the background as well. So I'm just going to kind of go back here, and we're going to do v2 for the configuration file. And the alert didn't change, so the alert file and everything stayed the same. Oh, I'm sorry, I'm in the wrong folder. So let's go back to the previous one. Go to task 8. We have we have one alert file, but we do have 2 log files. So that was new. Okay, great. Okay, so now it says, what is the number of the generated alerts? So let's go and find the generated alerts real quick. We have 68 generated alerts for this one. Next one is not 38, excuse me, 68. Very good. Okay, so now we can do the MX2 PCAP file using the main configuration file. So we're going to go ahead and clear the screen here. And we're going to run the same command, basically. We're just going to change it to MX2 PCAP, because I think the command itself is the same. So full alert, log inside of the current location, and we're just using the main configuration file. So we're going to press enter on that. There is the new log file that was generated. Okay, so now it says, what is the number of generated alerts for this one? So let's go and move to the alerts portion. And it is right above this, so it's right there. So 340 generated alerts. So there's that. Keep reading the output. What is the number of detected TCP packets? So that was also something that was up here. So 82 TCP packets were detected. And then now it says investigate MX2 and MX3 PCAP files with the default configuration file. What is the number of the generated alerts? So we're going to do both of them. This should be cool. This is the first one that we're going to get a chance to do. And instead of doing 1, we're going to end up doing 2. So it's going to be PCAP list is what we're going to do. So it's going to be sudo snort-c etc snort configuration -q -pcap -list equals quotations mx-1, right, .pcap, and then mx-2.pcap. And then we're going to close the quotes. And then what else do we need to do? We need to do an output onto the console. That's all we got. So it's going to read it. Wow, look at that. Awesome stuff. Where's the rest of my alert though, bro? That's not what I'm asking for. So the output needs to give me everything onto the screen. So what is the command that you gave? So full is what they did, and they generated the logs, and then they did the PCAP list. So I didn't do that. So let's go ahead and do console. Instead of console, we're going to do full. And then we're also going to do a log generated in our folder. And I think that's pretty much it. Oh, I don't need to do -q because that was the piece I think that I stole from the other command. So I need to actually delete -q. And then we're just going to leave the rest. Okay, there you go. I think -q is what kind of messed me up and didn't generate my full stuff. So it says, what is the number of generated alerts for this thing? So we're going to go up here and we're going to go to our alerts that are right here. So 510 alerts. No, that's not right, because this is a 4-digit response. So total alerts is what I think what we're looking for, because that may have been for the second MX2. So let's see what the total number of alerts is. My bad, I used the wrong PCAP files. It said MX2 and MX3, not MX1 and MX2. So I was supposed to use MX2 and MX3. Okay, so let's do that again. That is my bad completely. Okay, so let's go and see if we get 4 digits for our alerts. We do. So 1020 is the number of alerts. That seems more right. Okay, cool. All right, so now we can talk about the Snort rule structure. Okay, so the rule structure, thankfully, is really not that complicated. Okay, so you generate a rule, and this is a really, really good cheat sheet. And I very much love this because it's actually very, very easy to understand, at least in my humble opinion. So it breaks down into several columns, excuse me. So we have the action, protocol, source IP, source port, direction, destination IP, destination port, and then metadata is kind of what we'll call this over here. Okay, so the rule itself, the functionality of the rule is right here. This is basically it. And then the options, or the metadata, is the information that will display onto the screen to let us know what rule was triggered. Okay, so there are a few different things we can do. We can do, as an action, we can create an alert. We can create some kind of an actual action where it either drops it or it rejects it, and that's it, right? The protocol would be TCP, UDP, or ICMP. So anything apart from ICMP would either fall under TCP or UDP. And so TCP could cover a bunch of different ports or a bunch of different protocols. UDP could cover a bunch of different ports and protocols. So what comes down to is this portion right here. This is like the big piece right here. So source IP is where the traffic is being generated from. So any source IP and any port is usually the best way to differentiate or to kind of like signify where you want to limit or generate alerts from. And so if it's coming from outside of your network, then yeah, anything generated from any IP to any port, if it's targeting a specific IP and port that are sensitive, then we definitely you want to be included. So that's kind of a really key element right there. And then the direction is also another important piece. So if you look at these two different arrows, I guess we'll call them, the greater than and less than symbol, this is both directions. If you have both of them here, that means in either direction. So it could be from really any destination IP and source port or vice versa, right? So it's like all of them, the traffic back and forth will apply. So in this particular case, this rule will be triggered for anything that comes from any direction, any source IP or port, any destination IP or port. And then the options in the end are just kind of, this is an easier way to understand it. So this specific rule will generate an alert for each ICMP packet processed by Snort. So we see an alert on the left-hand side right here. We have the alert, the protocol's ICMP, the source and destination port are any, the source port and IP are any, the destination port and IP are any, and it's going in both directions. So if we look at this right here, alert, ICMP, any source port, any source IP in either direction to any destination IP and then any destination port is going to trigger this. As long as it's an ICMP packet or protocol, then it's definitely going to trigger this. And then the message that's going to pop up is, ICMP packet found. This is the reference for it. So you can actually put a reference CVE ID if you want to. This is not mandatory. You do need to put an SID, which is the alert itself, and then the revision number. So the alert has to be unique. The ID itself has to be unique. You can't have multiple rules for one ID. You need to have, for each rule, you need to have its own ID. If you're going to revise the rule, you can always change this, and then the ID can stay the same, just so you can kind of know which revision of the rule has been triggered. But if you're going to create multiple revisions for the same rule and the actual rule itself is going to change, then I would recommend also changing the ID so that you actually get to see the different versions of the rule. And then you can also change the message itself so that you can know exactly what it is that's being triggered. So these things are not mandatory for the rule to function. These are really more mandatory for the rule itself to function. So each rule should have a type of action, a protocol, source destination IP, source and destination port, and of course, the options itself. It's passive by default. Snort is passive by default. So most of the time you'll use it as an IDS. You'll need to start inline mode to turn on the IPS mode. But before you begin using that, it's essential to be familiar with the Snort's features. So the structure is easy to understand, but you already saw. Difficult to produce? Not necessarily. You should be familiar with rule options and related details to create efficient rules. It's recommended to practice Snort rules and option details for different use cases. We'll cover the basic rule structure. Okay, great. We're going to focus on alerts and then reject for IPS. Rules can be processed without a header. So this is what I mean. This is the mandatory part. Like the rule itself is basically those headers. That's what the function of the rule comes in. The rule options are optional, right? You don't have to have them, but you need to also just make sure that you have them just so you know what the hell is going on. So I would say it is a really, really good idea to have the rule options. But if you want it to just be functional, the actual header is the most important piece of it. So the action of the header would either be to generate an alert, to log the item, to log the packet, or drop it, or reject it, right? So block and log the packet is what drop would be. Block the packet, log it, and terminate the packet session is what reject would be. And that would be most likely what I would use. I would use reject instead of drop if I really want to activate the IPS more than anything else. Because if I'm dropping it, if I'm blocking it, then there's a good chance that I just want to also terminate that session for that specific packet. The protocol parameter identifies the type of protocol that was filtered. So Snort 2 supports only 4 protocols like IP, TCP, UDP, and ICMP. You can detect the application flow using port numbers and options. For instance, if you want FTP traffic, it would be TCP and then on port 21, right? So you can't do FTP traffic as the protocol. You would end up using TCP traffic, and then it would be port 21. That would be the rule. The port and the IP and the port numbers, excuse me. So these parameters identify source destination IP as well as the associated port numbers. So IP filtering. So alert ICMP from this port, right? Or excuse me, from that IP address to, from that IP address from any port in either direction to any of our IPs or ports. And the message would be ICMP packet from that specific IP address has been generated. This rule will create an alert for each ICMP packet originating from that IP address. Filter an IP range. So you can actually do a subnet in this particular case and do the same thing. ICMP, give it the subnet, and then all the rest of the rule stays the same. And then it'll create an alert for each ICMP packet originating from that subnet. So it can actually detect subnets, which is really handy. Multiple IP ranges. So you can use these square brackets and you can actually separate them by a comma, as you can see right there. So this is one subnet, comma, another subnet, any source port to any destination IPN port, and an ICMP packet found, and it'll generate it from either of those subnets. Exclude IP addresses and ranges will be done with the negation operator. And so this is the exclamation. Thankfully, this is like uniform across most languages and most rule sets. So you want to say, alert me for an ICMP not from this subnet. So as long as it's not from that subnet, so let's say that this subnet is something that we're going to use internally and this is allowed, so we don't mind if somebody from our subnet does a ping. So from any IP address outside of this subnet, then I want it to alert, right? So it'll create a rule that any ICMP packet not originating from that subnet is going to trigger that rule. So very, very useful. Port filtering. So alert TCP from any source and source IP and port to any destination IP, but specifically on port 21. So FTP port 21 command activity detected, an alert for each TCP packet sent to port 21. We can exclude port 21 with the same way of using an exclamation port. So it'll generate an alert for each TCP packet not sent to port 21. So basically to any other port other than port 21. You can filter a port range in this is so type 1 and type 2, and there's a type 3 and a type 4. Wow, okay. So this port range right here would be number 1 colon 1024, which will create an alert for each packet sent to ports between 1 to 24. So this is going between 1 to 1024, every port in that session. So including port 1 and including port 1024 and everything in between. The second one goes from any to port 1024. So it could be from port 1 to 1024, from port 5 to 1024, right? Generate an alert for each TCP packet sent to ports 1 through 1024, which is, I mean, it's kind of the same as anything else. I feel like that kind of feels a little bit weird. Or I guess it's like, I think this is actually, this any right here is referencing the destination IP. So this would be destination IP, and then there's a colon 1024, so ranging from, I guess, 0 to 1024, basically. So this one goes from 1 to 1024. This one goes from 0 to 1024, I think. But it literally says from ports 1 to 1024, so I guess that's pretty much the same as the previous one, because between one, oh, I see. I think, if I'm not mistaken, oh my God, let me zoom out. Let me extend my timer so I don't lose my machine session. I think what's happening here is that in the first one, it says sent to ports between 1 and 1024. So it doesn't include 1 and it doesn't include 1024. In this one, it's including ports 1 through 1024. Yes, that makes sense. And then this one is saying from port 1025 and on. So a source port that is higher than or equal to 1025. And it's not source port. This is supposed to be destination port because we can see it's on the destination side. So, but the arrows are going in both directions. So I guess it doesn't really matter. So that technically, I guess, does mean that it's going in either direction. So it could be a source or a destination. And then this final one right here, you're actually designating exactly which ports you want to do and separating them by commas. So it could be 21, 23, 53, like that. You could actually designate which ports you want to actually include in that range. The direction, this is kind of like a very interesting one. So this is one that I'm trying to get more clarity for myself. So this is the direction to follow. So it could be starting from anything, just moving forward. So source to destination flow, bidirectional flow. There is no backwards element of this. So it's just either moving forward from the source to destination or bidirectional flow. So in this case, we have a bidirectional flow of ICMP from any port NIP to any port NIP. There are 3 main rule options. So the general, which is fundamental rule options for Snort, payload, which help to investigate the payload data. These are helpful to detect specific payload patterns. Non-payload, that focus on non-payload data, which will help create specific patterns and identify network issues. Okay, let me see if I can zoom in on this in a little bit different way so we can get the full data of the information. So there we go. All right. So general rule options. So these are just our options, remember. So this is just a message field that helps you identify what's going on. The SID come with a predefined scope, and each rule must have an SID. So this is actually, it should not be part of the options. It should be mandatory because it says each rule must have an SID. There are 3 different scopes. So anything under 100 are reserved rules, so you can't use that. From 100 to 999,999 are rules that came with the build, and then anything higher than 1 million are rules created by the user. In previous practices that we've done, this was not the case because I was doing 100,001. So that technically, Yeah, I was doing 100,001. I was not doing 1,000,001. That's the issue right here. I was literally using these the ranges between this. So this kind of feels a little bit weird. The rules we will create should have a side greater than 100 million. Okay. Another important point is that SIDs should not overlap and each ID must be unique. Reference can be something like the CVE database or something else that you might want to use. This always helps analysts during the alert and incident investigation. And the revision, so the modification and updated for performance and efficiency of the rules. Revision option enables analysts to access revision information for each rule. Therefore, it'll be easy to understand rule improvements. Each rule has its unique revision number, and there is no auto backup feature on the rule history. Analysts should keep their own rule history. The rev option is only an indicator of how many times the rule has gone through revisions. So you can see this right here. This is not a must-have like this number for the SID. Now you can see the SID again here. This is 100,001. So this clearly, based on what they said, this is not a user-generated rule. Payroll detection rule options, so the content of this. So this is for payload data. It matches specific payload data by ASCII, hex, or both. It can be used multiple times within a single rule. However, the more specific pattern must match features you create, the more time it takes to investigate a packet. The following rule will get an alert for each HTTP packet containing the keyword get. So it says ASCII mode. This is the ASCII mode version of the rule. So alert TCP from any to port 80. Get request found content get. So content get meaning inside of the request itself, it found the keyword get. And then hexadecimal mode, same thing, but in this particular case, the content is now the hexadecimal value of get, right? So if you actually go to the hex generator and use capital GET, you'll get 47, 45, 54, okay? No case, disabling case sensitivity used for enhancing content searches. So anything and then put it inside of your options, get request found, content get, no case, so that you can see capital get, lowercase get, things like that. Fast pattern, you can prioritize the content search to speed up the payload. By default, Snort uses the largest content and evaluates against the rules. The fast pattern option helps detect the initial packet with a specific value for further investigation. This option always works. Case insensitivity and can be used once per rule. This option is required when using multiple content options. This following has two content options, and the fast pattern option instructs Snort to use the first content option. So right here, get request found, content get, fast pattern, content www. So fast pattern is going to focus on get, right? And that's the key piece right here. So Snort uses the first content option in this case. Instruct Snort to use the first content option for the initial packet match. And then I guess if there's another one that matches it, it'll use the next one. So it'll use both of them maybe. Maybe that's what it is. Kind of confusing for me on that one. No payload detection rule options. So the flags, these are actually very important. So filtering the IP ID field. So in this particular case, looking at an ID 123456 for the, I guess it says the IP ID field. So you remember, I don't know if you remember, but some of the questions that we had to answer at the very beginning, it was asking us for the IP ID. It may have been in the previous episode, but there is something in the report that actually has the IP ID. So you're looking for anything that will show up with that specific IP ID. So that's one of those things. The flags, so these are TCP flags, and these are actually very specific to TCP conversations. So when you do an Nmap scan, by default, it'll do the full connect scan, which will end up sending a SYN flag. Oops, excuse me. Let's close that. So it'll end up sending the SYN flag. It'll then send a SYN acknowledgement flag and then an acknowledgement flag. So that's the three-way handshake. We send SYN, the server sends SYN acknowledgement, and then we send acknowledgement. So Then there's the fin flag, there's the reset flag, the push flag, and the urgent flag. So all of these things are actually available for us to use as options in our detection. So if you do flags-s, it's actually going to look for SYN flag packets, which is very interesting. Then you can look at the payload size. So the data size, minimum and maximum. So you can do anything between the two. Then you can do anything greater than 100, anything less than 100, or anything in between. So in this particular case, we're looking at between 100 to 300 is what we're looking at. And then same IP. So the source and destination IP addresses for duplication. So any, and then we have same IP test, and then we just activate the same IP option. So a lot of options, as you saw. So once you create a rule, it's a local rule and should be in the local rules file. This file is located under that location, and how you can edit it is by using either gedit or nano. In this case, they're using gedit, and this is what the local rule files look like. Some of the rule files are activated with the Snort instance. They're activated to manage your rules and improve the exercise experience. So refer to task 10 or the Snort manual. So we got a lot of stuff, okay? So now we've actually covered it. So let's use the attached VM and navigate to the exercise file task 9 to answer the questions. And let's see if we can find anything of interest. And then we have task 10, points to remember. So we have made really, really good progress here. So let's go to task 9. So I'm already in the task 8 folder. So I'm just going to go ahead and move back to task 9. There we go. So there's that. And so we have the local rules inside of task 9 folder, and then we have the task 9 PCAP. So we're going to end up using our own PCAP. So it says use the task 9 PCAP, write a rule to filter for the IP ID 35369 and run it against the PCAP. What is the request name of the detected packet? You might use this command snort local rules because we're inside of the project file, so we should be able to just use that. Full log inside the local location, read the PCAP file. So we need to create a rule for the IP ID, and so it's literally, actually it was just here. So we were able to do it for the IP ID. Where's the IP ID portion? It was ID right here. So here's a sample of the rule. So here it is, and we're just looking for the IP ID. So I guess that's basically all I need to do here. So I can do, I guess, sudo gedit local.rules, because that's what they did. So there it is. And so now I can go down here and I can go and do the same thing. So alert TCP, any, both directions. And then we're going to do any, and then message is going to be the same thing. I'm going to do ID test. And then I'm going to do ID of, so what was the ID that we needed to do? It is 35369. And then we will do anything else for that ID rule. SID, so we'll do SID of 1 million, I guess. So 3, 1, like that. I think that's it, right? And then rev 1, and that should be it. So I think that's basically it. Save the file. Close the file. So if I cat this file, so if I cat the local rules file, there you go. There is my rule. Okay, cool. So now that we have this, so let's see what it looks like if we actually go ahead and use Snort to read this thing. So the configuration file is just going to be my local rules file here. We're going to do a full log in our location, and we're going to do -r of the task9.pcap. Here we go. Let's see what we get here. Okay, great. So now it says, it says what is the request name of the detected packet? So let me see if I can find this, because I mean there's a good amount of output here. I'm looking for the request name. Okay, so I didn't find anything for this, and so the hint says try filtering different protocols like TCP, UDP, and ICMP for ID 35369. So the only thing that I have right now is for the, I think the, what is it, the no, I'm sorry. So let's go back to the gedit here. And the only thing I have is TCP. So let's do the same thing and we'll just copy this. I'll do ID test and then we'll do TCP right here. So TCP ID test, and then we'll do the same thing. And then we'll just do UDP ID test, and then we'll do a ICMP ID test. So UDP, this one will end up being UDP ID test. SID will change to 2, and then this one will be ICMP, and then we will do the same thing where we'll change it to 3, and then we'll do the protocol will be ICMP. Okay, so that's basically it. And then 35369 is the ID, and I think that's it, right? And then that's basically all it says in the hint as well. So I think we're solid in that regard. So let's go ahead and save it, close it, and let's now go ahead and run the command one more time against this, and let's see if we can find anything. And again, we're looking for the request name of the packet that's detected. So I wonder where that would be, because it doesn't seem to be inside of the output here, unless I'm missing something. Hold on one second. I see. Okay, so it's actually inside of our alert file. And so the rule that was triggered was the ICMP ID test, because we actually see that right here in the description. And so the timestamp request is what was triggered. So timestamp request. Excellent. Beautiful. Okay, cool. So clear the previous alert file and comment out the old rules. Create a rule to filter packets with the SYN flag and run it against the given PCAP file. What's the number of detected packets? So here's what we're going to do. We're going to close this here. We're going to move that to trash, I guess. That's kind of one of my big approaches for all of these things, honestly. So we're going to do sudo gedit here, and then we're going to do local.rules. And so we can comment out the rules themselves by just doing it, a little hashtag here. So let's also do a space just to kind of make it clean. Okay, so now we are going to create a new rule. And it says to filter packets with the SYN flag, which is that -s that we saw. And so there's no hint here. Being that it is a SYN flag, I could technically rely on the fact that we're going to be using TCP, because SYN flags are usually relevant to TCP. So we're just going to try to duplicate that alert. So it's going to be alert TCP, any, and it's going to go to any. And the message is going to be, in this case, a SYN flag test, like that. And then ID is going to, I don't need to do an ID. Yep, I don't need to do an ID. So we're going to do SID, and it's going to be 1, 1, 2, 1, 2, 3, right? How many? Yeah, 3, right? Yeah, whatever. And then the rule itself is going to be that, rev 1, and that's our rule. Just like that. So if you want to see it, that's what we got. TCP, any. Message is SYN flag test. SID is going to be 1,000,004, I guess, right? Yeah, I think so. I don't know, man. I don't know how many zeros that is. And then revision of 1. So we're going to save it. I'm going to close that bad boy. And then we're just going to run it one more time. And it's literally going to be the same command, because we're running the same thing. The only thing that we're doing is we're just changing the rule set, right? So that's it. So we're going to press enter on this. It's going to generate our alert in the background. And let's go ahead and open up the alert file. There we go. Look at all this stuff. Wow. Okay, so it says, what is the number of detected packets? Okay, so this one actually we can go over here and see how many detected packets we get over here. So let's see how many they got. I made a very key mistake. There's a big piece out of this whole thing that really was missed, because it's supposed to have the flag in it, and I totally forgot that flag portion, and it doesn't have it in there. So obviously it didn't work. So that is actually my bad. So flags is going to be capital S here. And now we need to save it. So it's actually missing that key piece. That is literally the piece. What just happened? Let's go do that. Okay, there we go. Okay, so now it should actually work. So I made a very big mistake on that one. Okay, cool. So now we're going to go ahead and run that one more time. And so there you go. It should just be one because it should have only detected one. So it says an error local rules, rule options might be enclosed in this and that. And so what am I missing? Am I missing the rule option? So let's go ahead and look at the rule itself. The rule options must be enclosed. And I thought I had them enclosed. So flags, right? Flags S. The rule options are inside of their stuff. Oh, you know what? No, there's this last piece, that last thing right there. So that piece was good. Okay, now we fixed it. There was a semicolon at the end of it. There we go. Awesome. Okay, great. So now the question is, it says, what is the number of detected packets? So if we go up here and we find the packets detected, let's see how many we got. There is one packet detected. I had to delete the old alert file. So I did that before I showed you the answer. But if you don't delete it, it's just going to keep compiling and it's going to keep adding alerts into it. So you won't know exactly how many you detected and what the situation was. So there was only one packet detected. So we're going to go ahead and move that to trash. Let's move to the next one. Clear the previous alert. Okay, very good. Write a rule to filter packets with the push acknowledgement flag and run it against the given PCAP. What's the number of detected packets? So this one should be actually very easy because we should have exactly the same rule. We're just now going to put a comment in front of this one, copy that one, and then go ahead and enter a new one at the bottom right here. So now the flag itself is going to be the push flag, which I think is just the flags is P right here. So that's what that is. So we're going to go right here. We're going to do flags dash P. SID is just going to change to 5 right there. Save it. This should be very straightforward. And we're going to run the read. There we go. It's going to finish. We're going to open up our alert file. There's nothing in it. How's that possible? So does that mean that there was nothing detected? So if I do, no, that's impossible because it says there's literally 3 digits. So write a rule to filter packets with push and acknowledgement. Oh, I see. Push ACK flags and run it against the PCAP file. I did not read that part. Ugh. Okay, so flags S, and then I guess I should also do a flags A too, because it doesn't say how to separate them. So we can just do flags P, and then we can also do a flags A. So flags A like that. So that should be it. Okay. All right, so let's save it. Hopefully this will actually generate something for us, because as you just saw, the alert file is empty. So nothing happened here. So this time around, there should be something. Local multiple TCP flags option in rule error quitting. Okay, so what does that mean? Because if it's not supposed to be multiple, I guess so it's supposed to be push ACK like that. I think it's actually supposed to be push to ACK like that. No, but that doesn't make sense either, because how am I supposed to do that? This is actually kind of a confusing question for me, because it doesn't tell me how to do multiple flags here. It just says that you can do flags da da da. So is it saying push to acknowledgement? So should I do multiple rules, right? It says write a rule to filter packets with that flag and run it against the PCAP file. Oh my gosh. Okay, let's try a couple of things here. Okay, so evidently we actually would do it on the same line here, except instead of doing 2 different flags like this, we would do just a separation of the flags with a comma like that. I believe that's what it is. So now we're going to do, and we got to change this too, so it's going to be push ACK flag test like that. Okay, so let's try this one. I think that's it actually. So we're going to run it. There you go. It actually worked. Perfect. No error message. Okay, cool. Look at that. We actually got a response here. So now it says, what is the total number of detected packets? So this is the piece where I'm like, okay, well, I want to know, is it going to show me the number of packets? That's the thing that I'm most interested in, because I don't think it shows it to us here, the total number of detected packets. So I wonder if it actually has a packet number. So let's see. Okay, so that's basically it. So when you see alerts right here, that's the number of detected packets. And I think there's probably another section somewhere at the top of this that will also show the number of detected packets. And so if I kind of get us to the top here, right here, I think there's a way that also shows tagged packet. No, this is 256, so that's definitely not the number. It's the one at the bottom. So it's the alerts, right? The number of alerts that were set off. That's exactly what it is that we're looking for. It's 216. And I'm pretty sure it's going to be in the log file somewhere as well. But we don't need that. So we're going to delete those. And let's move to the next question. So clear it. Create a rule to filter UDP packets with the same source and destination IP and run it against the given PCAP. So UDP and then same source destination. So that was the same IP right here. So this is what we're doing. And we're going to do UDP though. So I wonder if I can just do like alert UDP and then do the same IP option. I think that's the answer. So let's try it. So just like everything else, we're going to open up our rule file here. We're going to go and comment out that one. And we want to, I'm just going to copy this just to kind of make life a little bit easier here. We're going to put it here. We want it to be a UDP rule, right? And we're going to just do right here. We're going to change this to UDP same IP like that. And then from there, we're going to just change this piece to read same IP. I think that's the actual rule name that says right here. Yeah, same IP. And then the SID is just going to change to 1006 or 1,000,006, whatever. Save it. And let's close this out. We've cleared out our alerts. So let's go ahead and run it. And so the question says, what is the number of packets that show the same source and destination IP addresses? And it's UDP packets specifically. So alerts right here show 7. So I'm going to try 7. Oops, not backslash. What is it? 7. It says you're going too fast. So I don't know if that's the problem. Let's see what the log shows us. That might be something of use to us. So if we do snort read the snort.log.177, what's in here? So running initializing, can't initialize, permission denied. Oh, I'm sorry, I'm supposed to do sudo snort r, my bad. Snort.log. Let's see. I mean, it does say 7 here too, though. UDP 7. Okay, so let's see. Let's try UDP same IP 7. Okay, that was the right answer. I was just doing it too fast. All right. Case example, an analyst modified an existing rule successfully. Which rule option must the analyst change after the implementation? They modified an existing rule, so that'll be the revision. And that's it for that one. We have made some really strong progress, I should say. And I think we just have a review. And then the conclusion itself is also just oh, that's a cool little cheat sheet. Super, super sick. I love it. I'm going to download this and I'm going to share it with our Hackaholics Anonymous community. Very, very cool stuff. Okay, so Snort 2 operation logic. This is just some modifications and notes, not modifications, I should say, some notes for you to keep in mind as you interact with Snort 2. So the main components of Snort is that it has a packet decoder. It actually allows you to prepare packets for pre-processing, preprocessors, the components that arrange and modify the packets for detection, the detection engine itself. All of these things really, honestly, you really don't need to know in detail, or you don't even need to know whether or not they exist, in my humble opinion. It's more about like actually knowing how to use the tool itself and relying on its functionality. If you want to go into coding and engineering, then it would be something good for you to know, so that you can actually expand on certain things, because it is an open source tool and it gets a lot of contribution from people inside of the community apart from its developer and apart from Cisco. So this is one of the things that, like, if you really want to go into the engineering element of security, then it would be a good idea to know this. And if that is indeed the case, you need more information that's what's available on this little screen right here. So it has a detection engine, it has logging and alerting functionalities and outputs and plugins, and these things all need to work together in order for Snort to actually function. Now the rules, so there are 3 types of rules, right? The community rules, the free rule set, publicly accessible. Registered rules, it's free, but it requires registration. So contains subscriber rules with a 30-day delay. And then the subscriber rules, which is for the paid subscription, that is main rule set updated twice a week, and then you get access to it right away. So you can read and download more, of course, from the Snort website directly. Snort.org/downloads is what it is. And ever since they created this room, obviously, there is now a Snort 3. And so you can learn more about Snort 3 and all of the new features that's been associated with it. After installing Snort, it automatically creates the required directories. If you want to use the community or paid rules, you need to indicate each rule in the configuration file. It's a very long all-in-one configuration file. So without causing misconfigurations is trouble, you need to use a text editor that will allow you to search so that you can find the different pieces to modify. Key point is to never replace the configuration file. Instead, edit the configuration file manually or update the rules with additional tools to prevent failures. That's the key point here. There's the configuration file, and then there's the local rules. So the rules are referred to in the configuration file, and then within that configuration file, you get to also leverage the rest of the parameters. Local rules just have the rules. So, for example, if you want to modify the local rules to include these various tags that are inside of the configuration, right? So the home net tag is where we are actually protecting. So this is going to be your network essentially. So you can do any, or you can actually give it a subnet. The external network represents the external network, so we need to keep it to any or to the actual home network itself, or where it says not home network. So you can see actually that exclamation, and then the way that you reference these things is by putting a $sign in front of it. So you want to do not the home network, or you want to just leave it as any. The rule path, so this is the hard-coded rule path, which is this location. The SO rule path, these are the subscriber rules. So that's what it is right here. And then the pre-processor rule path are for the subscriber rules as well. And that's the path for it right here. Then we have the decoder configuration. So the tag name itself, and then the various functionalities. So the IPS mode selection is under the DAQ. Activating the inline mode is under DAQ_mode. And then hard-coded default is the log directory. And so AF packet is the IPS mode selection. Inline would be that. And then, of course, the log directory is very similar to every other log directory in a Linux environment. Data acquisition modes are specialized libraries used for packet input-output, providing flexibility. It's possible to use this type for different purposes. So you have PCAP, AF packet. I think this is IPQ, yeah, inline mode on Linux. NFQ, inline mode on Linux. This one is for net filter, replaces the Snort inline patch. This one is just for Linux. IPFW, inline mode for OpenBSD, FreeBSD, and using divert sockets. Dump, testing mode of inline normalization. And most popular modes are the default PCAP and inline IPS AF packet. Navigating to step 6, configuring output plugins. All of this, by the way, is like, I would recommend that you have a tool like GPT or Gemini or Grok explain this to you in great detail, because this is way too much of an overview. It's like too generic of an overview. And if you really want to learn the best that you can, you would want to go into each one of these steps in great detail so you really understand what's going on. Because I'm not explaining enough in here, because it's literally just, I'm kind of reading through this and I'll drop certain points for you and we'll kind of make certain references. But if you really want to learn a tool like Snort, it's recommended to review the documentation, to use an AI tool to really help educate you with these things and do a deep dive on it. It is a very useful tool, and I think you should get mastery over this. So the configure output is the outputs of the IDS IPS action, so including logging and alerting format details, and it prompts everything in the console application. So configuring this will help you use Snort more efficiently to your liking. And then we have the customizing of your rule sets. So the site specific rules will be the rule path, the local rules. So this is an example of it. And then including that rule path would be the hard-coded default or downloaded rules. So these are the actual rules that you would download from the website, for example, the subscriber rules. The hashtag is a commenting operator. So you should uncomment a line to actually activate it. So when you do include right here, this is a commenting thing. So if you actually want it to be active, you would want to remove the comment, the hashtag, so that it actually activates the rule for you. And then you go right and you get it done. And more often than not, it's probably going to be in a different path. So whatever the rule path is, you would need to find that, and then from there you would need to go ahead and modify it by adding the location of the current rule set that you have downloaded. Again, I'm sorry if I rushed through this. It's not enough information. These are like just generic chunks of information. As I'm sure you can guess, there is a lot more information about this tool, and if you really want to get good at it, go through the documentation, use an AI tool to help you make sense of it and simplify it. There are a lot of things that you can learn about Snort. Okay, so in conclusion, we covered a lot of great stuff. Don't reinvent the wheel. I mean, these are just generic rules. Again, not rules, I would say. These are kind of like best practices. So understand the fundamentals. Don't create complex rules all at once. Don't reinvent the wheel. Try to use the rules that have already been created, or kind of enhance the rules that have already been created to customize them for your own environment. Always make a backup of the configuration files before making any changes, just in case you mess things up. Never delete a rule that works properly. Just comment it out if you don't need it. And do the same thing, like create backups of your rule files. So in case you really want to just kind of modify them for different types of environments, you can always just have your original rule sets. And then test the rules before migrating them to production by using the -T function. Now this specific file, which I think is a really, really cool file, I'm going to actually download and I'm going to have it available for you guys. I mean, it says everything that we already talked about in this video, but if you just want to have like a nice cheat sheet, I'm just going to download this and I'm going to put a link in the drive. I'll put it in like my drive, and then I'll just have it available to you so you can get access to it. Or I wonder, there should be like an easy way to do this, but I'm gonna just go ahead and download it and put it inside of the drive for now, and hopefully get a direct link to you. I just need to see the best way that I can share that with you, but I think that might be the best way to do it. If you get yourself a membership to TryHackMe, you can obviously get these kinds of things. And so if we look at the room options here, this is a free room actually. So anybody that has a free membership with TryHackMe can go ahead and download it. That is really cool that this is a free room. We did so much stuff in this room, and the fact that it's free and you get access to the virtual machines and everything for free, that's a really, really clutch resource by TryHackMe. So I would highly recommend just get yourself access to the free room, and the file is going to be in here. So just a username and password and you get access to this, and then you can download the file and you can practice with Snort inside of the virtual machine. That is amazing. I thought that this was for sure going to be a premier room, but it's not. It's a free room. So shout out to TryHackMe. I think they're very, very cool for doing this. This is like one of the better rooms that they actually have available for free for everybody. If you found value in this video and if you'd like to get more videos like this one, then I encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. There are so many different playlists that are live and they're being fed into constantly, including the new Linux Plus that's going to be coming out for 2026. Of course, SOC Level 1, PenTest Plus, AI for cybersecurity, a bunch of random videos that are obviously relevant to everything that we're talking about, but they're outside of these playlists. There's so many things that are available and they're going to be constantly coming out. So my recommendation is be a part of the community, be involved in the comment section, ask questions, check out the PenTest Plus or I should say all the CompTIA in general, all the CompTIA stuff, depending on which route you want to take and what you want to study. There's a bunch of different CompTIA resources available and people have actually used them to get jobs or to pass their CompTIA examinations, etc. So there's a lot of really cool stuff on this channel. And I'm not saying that just because I'm the creator. I'm saying that because I'm getting a lot of great feedback. And then in our Hackaholics Anonymous community, we have a lot of advanced users that are working in cybersecurity for companies. They've been in the business for a very long time, that they're involved in the community. And you can get access to them by being a part of our Discord chats and things like that. So if you haven't done so already, make sure that you like, subscribe, and turn on the notification bell. And if you really want to take it a step further, make sure that you check out Hackaholics Anonymous. If you want access to my notes and exclusive downloads and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I will see you in the next episode. Later.